So first day, we're just going over some basic definitions and how to write things shorthand. And even though chapter 1 seems really easy in geometry, it's actually really important because moving forward, I'm going to use all the shortcuts that I'm teaching you. So you really want to make sure that you're proficient not only in how to read the shortcuts, but how to write the shortcuts. And not to make the mistake because everything matters. You can't, you're not going to call a point a line, or you're not going to call a line array. So you want to be very careful with what we're doing. So here, first to start, a point is a precise location or place on a plane. Points are represented by dots. We use capital letters to name points. So I'm going to do a little example here. So let's say there's a point. I'm going to call that point P, capital letter P. Right, lines are made up of points. All lines are straight and extend infinitely far in both directions. Do you guys remember, what do we put on lines to show that they extend infinitely far in both directions? In the back, I wanna say it starts with an E. It does, right? No, you're Edwin. I know. Ethan. Okay. Arrows. We put arrows on the lines to show they extend infinitely far in both directions. Right, so now we name a line in terms of any 2 points on it. And I'm going to give you an example. So I'm going to skip number 1 right now, and we're going to go to number 2. So I'm going to shortcut writing this line. So in order to write a line and to shortcut writing it, what you do is you choose any 2 points on the line. The order does not matter. So I'm going to choose B and D to start. So you choose any 2 points on the line. And then what you want to do is you want to draw a line over it. And that represents line BD. I could have named this line DB. What's another way we could have named this line? BC, you got it. What's another way we could have named this line? CD, perfect. Do we get the gist? All right, cool. All right, now let's look at number 1. Now to start, I don't see any points, and then I see this lowercase letter m. So I don't have any points, and I see that lowercase letter m. I know this m is not a point. How do I know that this m is not representing the name of a point? 2 people. What's your name? Brendan. It's not capital. Good. It's not capital. This is not representing the name of a point because this is not capital. What this has done, this has been used to name the line. So sometimes what they do is they'll put a lowercase letter somewhere near the line, and that will be used to name the line. But when we're just using one lowercase letter, you don't shorthand it with writing the line symbol over it. So for this, you actually have to write the word line and then M. So this is line M. Okay, next vocab word is line segment. Can someone tell me, how does a line segment differ from a line? How does a line segment differ from a line? Next to PJ is Robert. It doesn't go on forever. If I wanted to take a ruler and measure a line, would I be able to find the length of a line? Never, because it extends forever. It never ever stops. All right, we cannot measure a line. But if I want to take a ruler and measure a segment of a line, would I be able to do that? Absolutely. A line segment has a definite beginning, a definite end. It has a length. So segments are made up of points and are straight. A segment has a definite beginning and end. A segment is named in terms of its 2 endpoints. Similar to a line, the order of the letters does not matter. So I have one endpoint R, I have another endpoint S, and I'm going to say RS, and then I'm going to not put a line over it. Guess what I'm going to put over it? a segment. Every segment is part of a line. Every segment is part of a line. So sometimes you'll see in the textbook, there'll be diagrams where I'm just going to give you an example here. Do we agree that RS is a segment? Do we agree that TW is a segment? But then when they go to tell you to do something with it, they'll say line RS or SR, and that's okay. If it's drawn as a segment, you can call it, they can call it a line if they want, because every segment is part of a line, and they need you to look at this as a line, not a segment. And that's why they're saying, okay, I'm giving you this diagram, but now I want you to look at this RS as a line, not a segment. And if you're looking at it as a line, not a segment, what would you visualize? That this is extending on forever. That's what it wants you to do. Right? So even though it's drawn as a segment, we know every segment belongs to a line. So they're allowed in the directions to sort of have you focus in that segment more as a line than a segment. All right, so we could call this segment RS, or we can call this segment SR with a segment over it. You all do number 2. All right, someone tell me one way to name this. I want to say Abby. Yes, okay.
Segment XY.
You got it. Segment XY. And even though it's drawn vertical, the segment, we still always write it horizontal. We always still write left to right. All right, what about another way to name this? What's your name? Casey.
YX segment.
YX, you got it. There's another Casey. Casey, okay. All right, measuring segments. So I know in the honors class, they're big sticklers about this. I really don't care. Technically, if you're saying a segment has a length, meaning, you don't have to write this down. I'm just giving you an example. So let's say I have segment AB, and I'm telling you this is 5 centimeters long. When they come to write it out, they're going to write AB equals 5 cm. What have I not put on top of this? What's your name? Sarah.
The segment.
Yeah, so they don't put the segment symbol over it. And the reason for that is they're saying, well, I'm telling you it has a length. So since it has a length, is there any way it could be a line? No, it can't be a line. And if it has a length, is there any way it could be a ray? A ray goes on forever in one direction, so it can't be a ray. So the only thing this could possibly be is a segment. So that's why they don't put the segment symbol over it. In the honors class, if you put the segment symbol over it, they would take a point off. In my class, I don't care. It really doesn't matter if you put the segment symbol over it or not, but just teaching you like the fundamentals there. Okay, let's keep going. So we talked about lines, we talked about segments, now we're going to talk about rays. Rays are made up of points and are straight. A ray begins at an endpoint, then extends infinitely far in only one direction. Now, a ray differs from a line and a line segment because in the previous two, the order of the letters doesn't matter. In a ray, it absolutely matters. Whatever kind of ray you have, the end point, the part that doesn't have an arrow going off of it, has to be the first letter written. So if you, let's say when we name a ray, we must name the end point first. So if you're looking at number 1, A is the end point, and then it's extending infinitely far past B. So the end point has to go first. Then after you choose the end point, then you could choose any other point to put on there. So then we'd say AB, and then what you do is you draw a ray over it. So for a segment, you draw a segment over it. For a line, you draw a line over it. For a ray, you draw a ray over it. So I know this seems pretty easy, but as the year goes on, all of a sudden I start seeing this. Why is that wrong? This is no. PJ.
It's just like identifying a point, not the line.
Well,
The ray.
the ray, exactly. So in order to name a ray, how many points must you use to name it? 2. 1 will never be acceptable. Okay, you must use 2 points. So we want to make sure that we're good on the basics. Now, for number 2, I know that this ray is going to the left. I know that. But when we write it, we don't draw it drawn to the left. We, in America, write from left to right. We're going to still write from left to right. So our ray symbol goes over here, left to right. And then you still write down the end point. Which point out of E, D, and C is the end point? Edwin? C is the end point. Then you can choose any other point. I usually choose the last one, so I'll say like CE. But if you wanted to write CD, you could have also written that. Also, as the year progresses and they see a diagram like this, some students will write CDE. No, we don't do that. No 3 letters, just 2. Okay. Up next, angles. An angle is made up of 2 rays with a common endpoint. This point is called, does anybody remember the pointy part of an angle, what we call it? Starts with a V. In the back, I want to say Kylie, but it's not. Kyla, okay.
The vertex?
The vertex. This point is called the vertex of the angle. The rays are called sides of the angle. All right, so angles are going to be our biggest thing here. There are different ways to name angles. Some are easier than others. I'm going to skip number 1 right now, and I'm going to go to number 2. The first way I'm going to tell you to name an angle is using 3 points, but the vertex point, the pointy part of the angle, that letter has to be in the middle. So looking at number 2, which point is the vertex? B, A, or C? Abby? A is the vertex. So that has to be the middle letter. So what we do is we draw an angle symbol. I always draw a loop through it so it doesn't look like an inequality. But a lot of kids get really upset with the loop. You don't have to draw the loop if you don't want to. It's fine. And we know A has to be in the middle. So I can either call this BAC or I can call this CAB. But the vertex must be in the middle. Another way you can name an angle, and when we get into proofs and our diagrams get really complicated, you're going to see me doing this all the time. What I do is I just go to the vertex, inside the vertex, and I throw a number in it. So I'll put like a 1 here. Now, I know, I wrote in this one, I know that I'm going to name this angle, angle 1. So you could just throw in a number, and then you can just call that an angle by the number. Now, the reader knows that this is angle 1 and not 1 degree because there's no degree symbol. If it was meant to represent that it's 1 degree, then there would be a degree symbol. If there's no degree symbol, that's just meant to represent the name of that angle. And when we, like I said, when we get into more complicated proofs, you're going to see me throwing in numbers for angles all the time just to speed things up. All right, and the very last way I'm going to tell you that you can name an angle is going to be to name it just by its vertex. Okay, so you tell me, if we were naming number 2 just by its vertex, what would be the name of this angle? Only PJ knows? Up front, what's your name?
Kellen.
Kellen? Okay.
Angle D.
Oh, no, number 2 still.
Oh. Wait, what was the question?
What would we name this? If we were naming number 2 just by its vertex angle, what would it be? On the outside, not the number, just by a letter. Angle A, you got it. So if we were naming it just by its vertex angle point, it would be angle A. So now the question is, well, Ms. Abdelbar, I'm always just going to name it by its vertex because that is the easiest way to do this. Yes and no. Right? You could only name an angle by its vertex if that is the only point. So if that vertex only belongs to this angle. If that vertex belongs to multiple angles, you cannot use the one letter way. And what do I mean? Go down to number 4. If we're looking at number 4, and I say, everyone look at angle O. Everyone look at angle O. With your fingers, show me how many different angle O's are there. Like, is there 1? Is there 2? Is there 3? Is there 4? Is there 5? How many different angle O's are there? I see a lot of 2's and a lot of 3's. All right, there are 3 angle O's. Where do these 3 angle O's come from? That's fine, Edwin.
Oh, like, you want me to name the points?
Yeah, well, yeah, tell me one angle O that you see.
P-O-Y.
You got it. You named it perfectly. Angle P-O-Y right here. That's one angle 1. Somebody name me a different angle 1. Brendan? P-O-R, did you say the big one?
Yeah.
This is the one everybody usually misses. Very good. P-O-R, the really big angle O. What is the third angle O? PJ?
Y-O-R.
Y-O-R, you got it. The third angle O is Y-O-R. So if I said everybody look at angle O, would you know which angle I'm talking about? No. So if there's more than one angle with the same vertex, you are not allowed to name it with just one letter. You're not allowed to do that. All right, so let's go through number 4 and answer some of these questions. What is another way to name angle 1? So angle 1 is right over here, inside here. What's another way? Next to PJ, I think you just told me your name and I forgot. Robert, okay.
Angle O.
We can't name it angle O. Why not?
Oh, it has like all 3 different angles.
Yeah, because angle O is all 3 different angles, so we can't do that. You want to try again?
No, not sure.
No, you got this, Robert. Look inside. Name it with 3 letters. That's what I meant to say.
P-O-Y.
P-O-Y, you got it. Angle 1, another way to name this is P-O-Y. Could I have named it Y-O-P if I wanted to? Could I have named it Y-P-O? Would that work? Good. Why am I not allowed to name it Y-P-O? Ethan.
Because the O's in the middle.
Good, because O has to be the middle letter because that's the vertex. Excellent. All right, let's go on to letter B. So now we want another way to name angle Y-O-R. So we follow the letters. You go from Y to O to R. So this is the angle. When I name an angle, you just follow the letters and trace it, and you'll always sort of highlight the angle. What's another way? Casey.
Angle R-Y.
Good. Angle R-O-Y. What's another way to name angle Y-O-R? What's your name?
Geo.
Geo?
Angle 2.
Good. Excellent. Angle 2. Can I name it angle O? No. All right. And last but not least, we are going to name angle P-O-R another way. We could name this angle R-O-P. Unfortunately, I'm not able to label P-O-R with a number because when you label with a number, that number has to go on the inside of the angle. And what's happened on these inside? It's already taken. Some people like to write like angle 1 plus angle 2. No, can't do that. So you only name this with 3 letters. That's your only option here. All right, we measure angles in degrees. right, another thing that the honors class is they're sticklers about is writing angle measurements. So if you write angle A is 55 degrees, you're good. But sometimes you see this. That M, and you're going to see it in the textbook, that M means measure of. You'll see this a lot in the textbook. And in this scenario, if we're going to say the measure of angle A is 55, you will not put the degree symbol there. You will not put the degree symbol because that M is telling you I'm talking about the measure, and we all know we measure angles in degrees, so should be known that this 55 is degrees because I put that M there. Like I said, in the honors class, they would take off points if you put the degree symbol there. I'm not that concerned with it. All right, classifying angles. An acute angle is an angle whose measure is greater than what number and less than what number. So if you're acute, what two numbers are you between? An acute angle. In the front, in second row, what's your name?
Me?
Yeah.
Olivia?
Olivia, was your hand up or are you just? Oh, I thought your hand was up. I'm sorry. Edwin. Good, 0 and 90. An angle whose measure is greater than 0 and less than 90. A right angle is an angle whose measure is exactly what? Oops, I put 9, not 90. Casey. 90. Now, when you draw a right angle, does anybody remember the little drawing we can do to represent a right angle? Next to PJ is John? Jack? What do we do?
It's a square.
Yeah, it's a little box. An obtuse angle is bigger than what number and less than what number? It starts with a C. Kellen.
90 and 180.
You got it. Greater than 90, but less than 180. So an obtuse angle looks like it's stretching back. All right, a straight angle. This is a big deal right now. A straight angle is an angle whose measure is exactly 180. This is a very, very big deal. Something we need to know. This is a straight angle. What does a straight angle look like? Casey? A line. A straight angle looks like a line, and it should look like a line. But in geometry, sometimes I'll draw a line and I want you to look at it as a line, and sometimes I'll draw it and then I want you to look at it as a straight angle. So how do we know? Is this a straight angle or is this supposed to be a line? Because they're two completely different things. All right. How do we know? I will tell you. So let's say all right, let's say I have this diagram. Do we all agree it looks like BD's array, and then it looks like I have a line? Or what else can this be? A straight angle, right? It could be a line, it could be a straight angle. You don't know. You won't know until I give you some given information. So let's say I wanted you to look at this as an angle. What would I have to write in my information? I would have to say, okay, angle ABC. By me now naming it angle ABC, now you know we're looking at this not as a line. We're looking at this as an angle, a straight angle, and we know a straight angle is how many degrees? PJ? 180 immediately, because now I've named it an angle. But now if I didn't want to name it as an angle, I wanted to name it as a line, I would say, okay, in diagram above, look at line AC. Now I'm naming it as a line. If I'm naming it as a line, can I apply that 180 degree rule anymore? Never, because now it's a line, it's not a straight angle. Do we see the difference? So do you understand when I said in the beginning that it's like such little things, but it means a lot moving forward? So we really want to be cognitive of how things are written because it makes a difference. All right, so that was something I wanted to point out. Another thing I wanted to point out, I think we might have to stop after this problem too. We'll finish up next class. Actually, hold on, sorry. I draw like this. Okay. Let's say I have something like this. I'm going to tell you angle, I want you to look at this as angle ABC is a straight angle. So here we go. ABC is a straight angle. So now we're in format, we're thinking angle, we're not thinking line. A straight angle is how many degrees altogether? 180. So straight angle equals 180 degrees. We know this. But now, do we see that the straight angle's been split? Right? It's split into different angles. We have angle 1, we have angle 2, we have angle 3. In order for angles to add together to make a straight angle, they must all come from the same vertex. What does that mean? Do you see how angle 1 and 2 share a vertex? Right? Does 3 share that same vertex as 1 and 2? No. What's the vertex for 1 and 2? The vertex for 1 and 2 are both point B. What's the vertex for angle 3? C. If they don't share the vertex, then they don't add up to 180 together. So in this scenario, I can say angle 1 plus angle 2 adds up to 180 together, but not angle 3 because it's far away. It's not sharing the same vertex. If there were another angle, let's say there was another angle here, 3 and 5 would add up to 180 together. Do we see that? No? Ethan, you said no? Okay. Do you see that 1 and 2 share the same vertex? So if they share the same vertex and they make a straight angle underneath of them, we can say they add up to 180. How come angle 3 doesn't add up to 180 with them? Because they don't share the same vertex. Do you see how 3 and the angle on the other side of angle 3 share the same vertex? So they would make a different straight angle together. They would make a straight angle with a different vertex. So let's say this is like Q. This would be angle QCB. It's like two straight angles going at each other overlapping because their vertices are different. What about in this scenario? And this will be the last thing I do. Will angle 1, angle 2, and angle 3 all add up to 180 together now? Yes. Why? Because they all share the same vertex. All right, we're going to end here. Call it a day. No homework.